Read the question carefully. Here we are asked to find the slope of the secant line correct to 6 decimal places for the following values of x. So secant line is just a line. So the slope would be rise over run for any line, right? And rise means change in y coordinates. Run means change in x coordinates. Okay, so that's that. Let's look at the P point. P is 2, -1. Let me write down here. P 2, -1 is a point, and Q is this point. I mean generic x 1 over 1 minus x. Now we can find the slope of this line, which is rise over run, and we denote slope by m, and for this line PQ, so m sub PQ. Rise means change in y coordinates, so 1 over 1 minus x minus -1 divided by run means change in x coordinates, x minus 2. Okay, let's simplify. So on the top we can negative and minus means +1. Now we can combine these two fractions. One we can multiply by 1 minus x over 1 minus x. I'm just making common denominator. And this one on the bottom we got x minus 2, 1 minus x, 1 minus x. 1 minus x is the common denominator. Here is 1, negative and minus and negative is plus. We got 1 minus x. So since this is plus, we don't have to distribute anything. So simply write 1 minus x. Okay, we combined these two fractions. And this one on the top, 1 plus 1, 2 minus x divided by 1 minus x. This is a complex fraction. Okay, it's divided by another. We can always think, okay, this is the original division. So we can think divided by 1. That means we change this division into multiplication. We flip this fraction, flip it. 1 over x minus 2. Or 2 minus x, x minus 2, almost same. When we have 2 minus x, we can factor -1 out. Then this becomes x minus 2. Okay, we can check by distributing -1 inside. This is negative x here, and then plus 2 here. So this one can be further simplified so that we can cancel negative factors out, x minus 2. Okay, x minus 1, we can do the same thing so that we can cancel negative sign, x minus 1, factor negative out. So let's write x in the first place, times 1 over x minus 2. Okay, this is also a block. Then we can cancel x minus 2. X minus 2, here is -1, -1, we can also cancel those negatives. Okay, and that leaves the slope is 1 over x minus 1. Let me write here, 1 over x minus 1. For generic x, the slope is 1 over x minus 1. Now in part A, we need to find the slope for different values of x. And if we look at closely, 1.5, 1.9, 1.999, okay, they are marching towards 2. On the other hand, 2.5, 2.1, they are decreasing towards 2. Okay, they are decreasing towards 2. So we have two different groups. So we will be using this slope to calculate the actual slope, because this is for generic x and y. So we can make a table, okay, where we got x values in one column, and we can find the slope in the second column. Okay, x values and the slope. Slope is here. Slope is denoted by m of this secant line PQ, which is given by 1 over 1 minus x, 1 over x minus 1. Okay, let's do the first three. In 1 we got 1.5 plug in here. 1 over parenthesis 1.5 minus 1. They are together, okay? So you in calculator, you might have to write 1 divided by parenthesis 1.5 minus 1. And write down the values. Okay, I have calculated in advance using calculator. So it's going to be 2. In part 2, we got 1.9, 1 over parenthesis 1.9 minus 1. And then 6 decimal places, 1.111111. In part 3, 1.99. Plug in here, 1.010101. And fourth, we got 1.999, very close to 2. That comes out to be 1.001001. Okay, and we got other numbers. I'm going to use a different table. From these, we can see these numbers are going towards 1, because 1.00 means just 1. Okay, so let's make another table for other values. So we have x values, and we are trying to find the corresponding slope m for pq, which is 1 over x minus 1. 5, 2.5, plug in 2.5 there, you're going to get 0.66666 forever. Then 2.1, plug in here, 0.909091. Then 2.01, we get 0.990099, and finally 2.001. So we're gonna get 0.999001. Okay, so that's the different slopes. In part, this is part A, okay? In part B, they ask, using the results of part A, this one, guess the value of the slope of the tangent line. Okay, and we know that the slope of the tangent line is the limiting value of the slope of the secant line. From here, clearly, we chose the numbers. These numbers are designed to go closer to 2, and the slopes are going towards, they are decreasing towards 1. Here, these numbers are chosen so that they go to 2, so the slope of secant lines are going to 0.999, means very close to 1. So the slope in each case, when we approach to 2 from left, in fact this is from left and this is from right, the slope appears to be 1. Okay, so guess the slope. So it appears to be 1. Okay, that's the slope of tangent line. Now in part C, we are asked to find the slope from part B, which is 1. Find an equation of the tangent line to the curve. So equation line means y equals mx plus b. Okay, or we can use equivalent formula, y minus y1 equals slope x minus x1. M is slope, x1, y1 is the given point. So we are finding the slope at 2, -1. Okay, part C, look at the question, 2, -1. So this point is x1, y1. So we y minus y1, x1, y1 minus 1, y minus -1. Slope, that is 1, x minus 2. Okay, we're going to put this in y equals mx plus b. So this is y plus 1, distribute 1, x minus 2, subtract 1 from both sides, Okay, that's the final, and that's the slope here.